Hello, everyone. Really excited to be here. It's nice to be able to talk with you again. We have some really exciting memory and storage topics for you today and some really great speakers. They will be introducing themselves in the next few minutes. So today I have an easy job. I'm just here to kick us off with a quick refresher of the memory and storage hierarchy and just kind of re-share with you our vision of how we're modernizing the traditional memory and storage tiering. This will help set the stage for some of the exciting usages that you're going to hear about today. So I'll start by, let's just look at this illustration of the traditional memory and storage pyramid, but with it, I've added a really large visual gap that we usually don't show. We tend to think of this pyramid as a contiguous set of tiers. Storage tiering has been going on for decades, but in reality, the performance and capacity differences between SSDs and DRAM are actually quite large. Starting at the bottom of the pyramid, as I mentioned, you can see the multiple tiers of storage today. I know that concept isn't new. From tape to HDD, moving to NVMe from SATA to SSDs from HDDs, the tiers for storage have really gotten more mature and granular over time. And if we look at it from the tops down, even in the CPU, we've added tiers every time we see a 10x improvement in performance in levels of SRAM or cache on the processor. So it just raises the question, why do we still have this really large gap between memory and storage? And why are we choosing to address it now? You know, the answer is we just didn't have a good option with the right characteristics, cost, latency, capacity, and persistence to really be able to fill that gap. And then today's workloads are actually starting to demand that we resolve some of these gaps so that we can get the right performance for real-time analytics or the right affordable capacity for memory. So from data set sizes, when we talk about the workloads, everything from the size of the data set, the locality of the data, the access patterns are changing, actually the sizes of the instructions. We've just really seen a lot of change, and traditional storage tiering is really starting to reach its limits in this gap area and creating some bottlenecks. And as luck would have it, Intel now has a portfolio of Optane products that have those right characteristics of latency, cost, density, and capabilities to really start building these new tiers. These products are really flexible. They can be deployed as either memory, for me that means byte addressable, or storage, which means block addressable. And then depending on the use case, you can pick and choose the characteristics of that tier that you really want to optimize for. So you might be looking for performance or a certain access pattern or access from the DDR bus versus the NVMe bus, persistence or volatility, cost, capacity, or even endurance. And so this innate flexibility of these products really gives us an opportunity to rethink about the way we architect our memory and storage tiers. Now, unlike traditional storage tiering, it is a new concept to talk about having a natively persistent new memory tier. That really is kind of a new memory tier. That's a new concept. And in some ways, it's an intuitive leap that you can tier memory just as easily as storage. Now, this is how SAP HANA, we've talked with you about SAP HANA before, this is how they use PMEM. Direct load store access at DRAM speed, but it's persistent and large capacity is affordable. Creating two tiers of memory is now possible and dare we say even becoming mainstream in the future with DRAM as that thin performance cache tier and PMEM as the capacity tier. But what about using PMEM as a storage tier? So this is how Oracle Exadata uses PMEM. PMEM is the thin performance tier to the NAND SSDs, but it's really a new twist on a storage tier because it's byte addressable and it's located on the DDR bus. This opens up a whole new world of opportunity like replication over RDMA or application placed data to minimize software overhead. So Oracle is just one example of the new types of tiers, and today you're going to hear about some other creative solutions as this industry develops. And of course, I don't want to overlook that Optane SSDs make a great storage cache or tier paired with the Intel NAND SSDs for plug and play storage acceleration. And I would be remiss if I didn't mention the new P5800 is billed as the world's fastest SSD. So a great new tier for the storage tiering. So today, our presenters are going to share some more examples of how PMEM, Optane SSDs, and the Intel NAND SSDs are being deployed in either memory or storage tiers to help make these concepts more real. I always like to say that storage at memory speeds and affordable high-capacity memory, they're not just taglines anymore. We have real customers doing these things today, and these are really new variations on traditional memory and storage tiering.